Welcome to EDGEcast, the series where we show you tips, tricks, and best practices when using Solid Edge. In this episode, I'll show you how to use the multi-body modeling tools to generate an assembly while still in the part environment. First, I'll explain how to create a multi-body model and show the main available Boolean operations. I'll also discuss active bodies, how to create a part containing both part and sheet metal bodies, the difference between design and construction bodies, and finally, how to publish a full assembly and draft file from the finished part. When in the normal part environment in Solid Edge, by default there is one design body which you add and remove material from. However, the add body command allows users to add more. But why is this command useful? There are two main applications. The first is that when operating on one design body, the Parasolid modeling kernel has a number of rules that cannot be violated. For example, the non-manifold body rule, which dictates that edits that create solid geometry with infinitely small thickness in any point will fail. The easiest way to show this is with a simple demo. In this case, I'm trying to make a part which is logically impossible, connected to another extrude at a single point, but still the same part. There are two ways in this case to create geometry like this. Either I need to make sure the sketches intersect and provide at least some connective material between the two extrudes, or I can create the second extrude as a second solid body. Separate bodies can intersect in any way the user likes, meaning that there is more freedom to create highly complicated geometry without being limited by non-manifold conditions. Another possible reason to create a multi-body model is that it allows a user to contain all data for an assembled product in a single part file while under development. Let's give you an example. Here I have a part, a simple phone handset. My aim is to create a docking station and wall mounting bracket for this phone, all in the Solid Edge part environment. Now before I start modeling the docking station, I need to open this Add Body menu. As you see here, we have the Add Body command, along with a few others. I'll be using this menu extensively today. To start with, let's add another body to this part. I'll call it Docking Station. I'll also rename the first body as Handset in the feature tree, so that it's easier to keep track of in Pathfinder. Once I've done this, the handset becomes translucent, a sign that I'm in the multi-body environment. I'm no longer editing the handset, but a separate set of geometry in the same space. Now I'll create a nice simple base feature for the docking station. Let's make a plane offset from the base coordinate system, because I'm in ordered mode and I don't want to link a base feature to something that's likely to change, such as a face in the handset. In synchronous mode this wouldn't really matter. 200mm by 100mm should be large enough. I don't want a very big docking station, although I can easily make it larger with dynamic edit later on. And a depth of 45mm will leave 15mm of phone for the user to pick up. So let's try that. Maybe a more ergonomic front surface would be better. What if we replace the front face with a curved surface? You'll notice that I can pick up on key points in other bodies without needing to switch on peer geometry, as I would in an assembly. That makes everything a little quicker. Now let's finish this surface. And start the replace face command. And there we go. Much better. I'll finish this body up with some rounds. Let's say 10mm on these front edges, and 2mm on the back face edges. I'm right-clicking to accept the displayed input each time, in case you were wondering. Now I have a phone body and docking station intersecting each other, which will never work in real life, but now I'm going to create a cutout in the docking station to exactly fit the phone. To do so, I'll use a Boolean command, specifically the subtract. These commands are mathematical operations, all designed to create and manipulate design bodies in a part. The main ones are union, which joins together two intersecting bodies, subtract, which removes the intersecting geometry of one body from one or more other bodies, intersect, which creates a brand new design body where two or more overlap, and split, which cuts design bodies into more bodies by using a splitting surface or another design body. All of these are available in both synchronous and ordered modes, but in ordered mode, the different design bodies retain the history of how they were created, meaning that any changes to the tool body that created them will cause an automatic update. When I subtract my phone from the docking station in that case, as I'm in ordered mode, any changes made to the phone handset will change the geometry removed from the docking station. Let's see what happens. I'll go ahead and start the subtract command, and you'll notice the prompt bar asks for a target body. In this case, it's the body we're removing material from. We can have multiple target bodies, but we just need the one here. Next, I'll need to select my tool body. There can only be one tool per subtract, by the way, and in this case it's the phone. My options in that case were set to keep the tool body visible, so we could still see both. But let's see the result without the phone body visible. Expand this list of design bodies high up in the feature tree, and let's untick the handset. Now you'll notice there's a small problem. The holes from the handset have also been added to the subtract. But this is ordered mode, remember, and I modelled the holes as two holes, a pattern, and a mirror, one after the other. These are the features, in fact, so let's group them all together and change the part history so that these features are calculated after the subtract operation. For more complicated Boolean operations such as this, I would recommend ordered mode over synchronous. You'll have noticed that during that process, the phone was translucent, but the docking station being edited was opaque. That's because the docking station was the active body. Active bodies display as opaque, and also show with a coloured design body icon in the feature tree. As a rule, you can only add or remove material from an active body, and only one body can be active at any time. However, holes, rounds and cuts can now be added to both active and inactive bodies, as there's a body selection step in both hole and cut commands. Rounds can be added to any body, similar to adding assembly features. However, if you need to add geometry to a body, then you can activate it by right-clicking it and choosing Activate Body. Before we do more with active bodies, I want to split my docking station in two and thin wall both halves, so that I can add the necessary electronic components at a later date. Once again, I'll add a sketch to the base coordinate system, as this won't change position. I'll create a very rough sketch, and then create a surface that goes all the way through the part. Then I'll start my split command, select my target, which is the docking station, and my tool, which is the surface I just made. This creates another design body, which I'll go ahead and thin wall as it's active. A wall thickness of, let's say, 1 mm should work. Now let's see the result. This thin walled successfully, so I'll hide it and activate the front half. But instead of having to right-click it, I'm going to activate it by double-clicking the body in the feature tree. Just another shortcut. Now let's thin wall the front by the same amount. Now we have 3 design bodies in the same part. And before we go any further, I'll rename this front half so that it's easier to remember. There are a number of actions you can carry out on bodies by right-clicking them, by the way. One example is Activate Body. However, my personal preference is to double-click the body in the feature tree to activate it. Below the Activate option is one that looks similar but is completely different. Activate Assembly Body does not affect the multi-body part at this level. However, if it's used in a top-level assembly, only one body can be active at any one time and have assembly features applied to it. This body is specified by using Activate Assembly Body, a command only available when editing the multi-body part. Once you've specified a body as an active assembly body, a small assembly symbol will appear next to it in the feature tree, as we can see here. As I mentioned, body activation is important for most operations, such as the earlier thin wall, but now I'm going to add some rounds to inactive bodies. The handset is currently active, but I want to soften the corners of this docking station where they meet the handset. In a production part, I would do this before the thin wall. There we go. You can see that the rounds are removing material from the inactive body. Now let's go ahead and speed things up. There should be 2 convenient edge chains for me to select in this part. And no more sharp edges. Now I'm almost done, but I want to add one more body, a wall mounting bracket for this phone, and this means sheet metal. This is perfectly possible in a multi-body part. Sheet metal bodies and part bodies can be created in the same file if needed, although they will all need to be the same material, and if all are sheet metal, then they'll all need to be the same gauge thickness. Another thing to remember is that a multi-body part can contain one flat pattern, but if 2 or more bodies are available in the part, you can't flatten them both at the same time. Before I add this sheet metal body though, I'll paint the docking station bodies, as this doesn't apply material. Remember that Part Painter has a body option, which normally applies the colour to the entire part, but not here, as it's a multi-body part. Now I'm ready to add another body, but instead of using the part option, I'll select sheet metal body for the first time, and call it mounting bracket. For the first feature of this new sheet metal part, I'll sketch directly onto the back of the docking station, as I always want my bracket to fit around this part. The idea here is to use the existing geometry to drive key dimensions in the resulting sheet metal part. If you're familiar with IntelliSketch, this might be a good time to deactivate some automatically generated sketch relationships and add them manually. I'm making this with speed in mind, not precision, but in a more complicated multi-body part, changing IntelliSketch options may well save time. Now everything's fully constrained, so I'll finish the sketch and use it to create a new tab. Now for some flanges. There's a bit of a gap here, but that's entirely due to my flange options, which I can always change. I can fully constrain my flanges based on existing key points so that when my docking station changes shape, so does the sheet metal body. One more flange on this side, I think. And now we'll add some wider bends on the top of each. If you remember, the round radius was 10mm, so a bend radius of 10mm will exactly match the flange to this round. And flange options we can always toggle back so that the bodies don't intersect in this case. Now that's half the flanges done, and I'll take this opportunity to remind everyone of the golden rule of CAD. If possible, reuse your work. In this case, with the mirror command, I can reflect all 4 flanges about the ZY plane. One more flange at the bottom shall finish the bracket. We're almost done with this, but now we need to add a hole for a 12-volt power cable, which I'll add as what's known as a construction body. In the right-click menu I showed earlier, when selecting bodies, you'll have seen an option to toggle Design and Construction Bodies. Multi-body parts don't need to be entirely made of solid geometry. Some bodies can exist as collections of surfaces, which can be used for all Boolean operations, but won't contribute to volume and mass calculations, or parts lists, and don't show up in drawing views by default. They'll also not be generated as components when using the multi-body publish command, which I'll show later. They are, however, extremely useful when trying to precisely design an assembly around something that you don't want to see in the parts list, drawing view, or final assemblies. For this project, I've been given a connector part by my suppliers to build my multi-body part around. So I'll use the insert part copy command to bring it in as a linked body. In this case, it's the 12-volt DC input file right here. Any changes made to this part will be reflected in the multi-body environment, and it's being copied as construction, not design. I'm happy with this input, so I'll accept and end up with this body. This distinctive purple colour indicates that it's a collection of surfaces, and a new construction body appears in the feature tree, once again coloured purple. Now you'll notice that this component's been brought in with an incorrect orientation, so I'll need to use the move face commands to move it into position. This would be easier in synchronous, but in ordered mode we have history-based links between bodies, so that's the environment I'll be using for now. I'll rotate this DC cable about the x-axis by 180 degrees, and then down by using 2 key points. And now into the middle of the back of the docking station. I don't recommend using these move face commands extensively, as they make your feature tree a bit large. If I wanted to use this adapter to contribute to parts lists and mass calculations, I would toggle it to become a design body. But I don't. This is just for reference, so that I can remove material. Once again, I'll use my subtract command, this time using this part body and this sheet metal body as targets. I will accept and define the input cable as my tool body. This time it'll be hidden, as it's a construction body, not solid, and my command options are set up to hide it once it's been used in this subtract. To finish up the sheet metal part, I'll add a set of dimples and holes from my feature library, as there's another bracket I made with exactly the same layout of dimples and holes. If you're curious about how feature libraries work, I'll be making a future EDGEcast episode on the topic. So now we've completed a multi-body part, and it's time to draft it. Multi-body models can be displayed in draft in a similar way to assemblies. Every solid body will show up in every place drawing view. If users right-click their multi-body drawing views, though, they can also individually hide and show bodies with the Display tab, essentially creating configurations of the multi-body part. Let's create a new drawing of this active model, using the default draft template. As I'm placing views here, you can probably see this looks exactly like an assembly. Let's start drawing view properties, though, to show you what to expect. Here are the 4 solid bodies, as expected, and if you select them individually, the Show Hide checkbox will allow their display to be more accurately controlled. I'll go ahead and change the display for this isometric view to shaded, but before closing and updating, if you remember we still had construction surface bodies in the multi-body part, which aren't shown by default in draft. If I want to show them, I'll need to click on this menu button here, the Parts List Options, and then List Constructions. Now all the surfaces will show up in this parts list and can be individually shown and hidden. However, be a little bit careful with showing all of them, because in the original part model, if you remember, I used construction surfaces for creating curved geometry. And if I carelessly show all of them, yes, my connector will show up, but so too do all of my unwanted surfaces. This is why naming all of the bodies you want to show is important. If I had only shown solid body 11 surfaces, the unwanted surfaces would have stayed hidden. One very quick hide later, and I'll try to add a parts list to this model, as this is where users have to remember the difference between a part view and an assembly view. As you can see, this parts list has one item in it, the multi-body part, and that's because, despite all appearances, this is still only one part, and parts list properties won't work in the same way as drawing view properties. If I wanted to create a parts list from a draft of this file, I would need to generate an assembly first. So how do we do this without remodeling? The answer is to use the multi-body publish command on the same drop-down menu where we found our Boolean commands. This command creates an assembly file and multiple linked part files, each of which appears as a part copy linked to the multi-body part. After that, if you want to edit the assembly components, it's best to edit the multi-body model itself. So to fully explain what I mean by that, let's show the process. Boolean menu, then multi-body publish. And we'll keep the create assembly option ticked. Each file can be saved to a different location by selecting it and choosing the Set Path button, but I want to save to default locations, which are the same as the original multi-body part. So let's double check the options. We're generating an assembly, and all the parts are set to the right path. Time to save the files. As you might expect, the bigger the model and the more bodies there are, the longer it'll take. Now let's open one of the parts that we've just generated. The handset will do. You can see in the feature tree that none of the features are displayed. This is only a link to the original multi-body part. This is what I mean by saying all of your product definition is stored in the single file, the multi-body part. Now let's take a look at the linked assembly, using the same multi-body menu as a shortcut. You'll notice when we do so that there's an assembly copy in here, which also links directly to the part file to obtain the positions of the bodies. That means you can't move these bodies around with normal assembly commands, like the steering wheel, which, when we select something, doesn't show up. Once the assembly and parts have been saved, though, this assembly can be drafted, parts can be assigned their materials and other attributes, and a parts list can be generated for production. And all of this achieved while keeping all of your geometry in one file. Thank you very much for watching. If you have any questions, topics you'd like us to cover in future episodes, or other feedback, please either leave a comment below or send them to us by email at support@cuttingedge.co.uk. And be sure to tune in to watch the next episode of EDGEcast.